Hello, my name is Waleed, and today I will be doing my first lesson on SPH3U, or grade 11 physics. So to begin, the first unit that is typically taught is kinematics. But what is kinematics? Well, kinematics can be described as the study of motion. Study of motion. For objects, typically, or people. But this could be described as what's happening after you kick a ball, when it's moving in the air and all those things. But to understand how those problems work or how we can solve problems like that, we have to understand a few things first. We have to understand what distance is. Distance is the total path taken by an object. Total path taken by an object. And a symbol that we typically use is just going to be AD. And units we can measure in meters, kilometers, centimeters, etc. Okay. And a formula we could use could be delta D is equal to D1 plus D2. The delta typically just stands for a change in a value. So if you're ever wondering what delta is, it just means a change in a value, which is often seen in grade 11 physics and grade 12. So to understand how we can use distance, we can try to do it here. It says in the figure above, how far will you travel if you walk directly from home to school? So that's for part A. From home to school, it's already given to us, and it just says 500 meters. So here we can just write D is equal to 500 meters. The next part says, how much will you have traveled if you walk from your school to the library? So from school to the library, then you return home. So you go all the way back here. So before we can begin that one, because this is like a little more difficult than the last one, we can use the grass method, and we can just go our given. We know our D1 is going to be, or our first distance is going to be 1,200 meters minus 500 meters. The reason we know this is because from the school to the library is the distance we don't know, but we know the total path from the home to the school is 1,200, and from the home to the school is 500. So from home to library is 1,200, home to school is 500. So if we subtract those, we'll get this distance right here, which is equal to 700 meters. From here, we can just go D1 is equal to 700 meters. D2 is equal to, then it says then you return home, which means from the library back to home, which is 1,200. So we know D2 is equal to 1,200 meters. Our required to find is just going to be our delta D, and then from here we can just go delta D is equal to D1 plus D2, and we can just solve solution, which is going to be delta D is equal to 700 meters plus 1,200 meters, which is equal to 1,900 meters in total. Next thing we'll be looking at is position and displacement. But to understand what those are first, we have to look at what a scalar is. A scalar is a measurement with only a magnitude. So measurement with only magnitude. This can also be referred to as size. So if we look back here, we know that our distance is actually going to be a scalar because we're only looking at a size or a magnitude. The next part it says here is a vector. So what is a vector? A vector is basically a scalar but with direction. It has both magnitude and direction. So it has magnitude and direction. And this is typically represented by a arrow. So if you ever see something like this, we know that is going to be a vector, not a scalar. And because we look up here on our distance, there was no vectors on here because we weren't taking into account his direction. We were only looking at his magnitude. Next, we're going to be looking at position. Position is basically the distance and direction of an object from a reference point. So distance plus position of an object from any given point. The symbol we can use for that is just going to be a D, but with a vector sign, because we are now taking into account its direction. What's a reference point? A reference point is just a starting point. So this is typically given, or we'll know what a reference point is depending on where the question says we start from. Displacement is typically an object's displacement is the change in its position. So it's just a change in position. And the symbol for this is going to be a delta D vector. The reason this is the case is because we know that it has a direction. That's why we use a vector. And we use delta because it's going to be a changing value from just our position. A formula we can use for this is going to be delta D vector is equal to delta D2 vector minus delta D1 vector. That is typically a formula that we can use depending on the question. So let's look at this, what's down here, and let's try to solve. Oh, also what is delta? Let's say change in value. So it says in the figure above, what is the position of the school with home as a reference point? So if we're starting at home as a reference point, what is the position of the school? Well, we can just know this to be D vector is just equal to 500 meters. We know this because from here to here, it's going to be 500. It says the position of the school with the library as a reference point. So position of the school with the library as a reference point, we know from here to here, we can account for it to be, again, I believe 700 meters. But because we're using reference points, technically, we actually have to take into account the direction. So we can write 700 meters down here, but 700 meters from the library, from the school to the library is going this way. So we know that this is going to be east. So 700 meters east, actually. And above here, it's actually going to be 500 meters east as well. For the next part, it says, I walk from 1 meter west to 3 meters west. What is my displacement? So we can just do a simple given. We don't need to, but it's good to build that habit. For now, because we're going to have different directions, we should set directions as positive and negative. The reason we do this is to actually save time at times, because we can go 3 meters bracket west every single time and describe what direction we're going in, or something simpler would just be to write a direction as positive and then the other will be assumed as negative. So for example, if we go, I walk from 1 meter west to 3 meters west, we can just at the beginning just put west is equal to positive. And you'll notice that I walk from is actually a position. So we can go D vector is equal to 1 meter or D1, sorry. And then D2 vector is equal to 3 meters. And now we're just looking for our required to find is our displacement, our delta D. And for this, we can just go analysis. We can go delta D vector is equal to either D2 minus D1, or in this case, we can go delta d vector is equal to d vector 2 minus d vector 1. So in our solution, we can just go delta d vector is equal to simply 3 meters minus 1 meter, which is just equal to 2 meters. The next thing we're going to talk about is total displacement. Total displacement is basically the sum of all individual displacements. So the sum of all individual displacements. And the formula for this that we typically use is delta d vector is equal to delta d1 plus 1 plus delta d2 vector. And we're still using the symbol delta d because we are still working with displacements. So an example for this question, we have one here. A dog is practicing for her agility competition. She leaves her trainer and runs 80 meters due west to pick up a ball, then carries the ball 27 meters due east, then drops into a bucket. What is the dog's total displacement? So for this question, we're actually moving in two different directions. So let's set one direction as positive and the other will automatically become negative. So we'll just go ahead and set west is equal to positive, but it doesn't really matter which one you set as positive and which one you set as negative. So we know that this is the trainer. The dog runs 80 meters west. So her first delta d 1 is going to equal 80 meters. And then the dog runs this way. So then it runs 27 meters. So we can go delta d1 is equal to 80 meters vector, and delta d2 is equal to negative 27 meters. Why do we set it negative? Because instead of writing that the dog went east, we can simply just make that direction just negative. Just like if you made this side, if you made east is equal to positive, then that would mean west would equal negative. It doesn't matter which side you set as positive or negative, it's simply up to you. From here, we can go into our required to find, which is going to be a delta d vector, because we're looking for our total displacement. So we can go straight into our analysis. Our analysis is just going to be our formula, which is just delta d vector is equal to delta d1 vector plus delta d2 vector. And you'll notice we have both of those right here. So we can go straight into our solution, which will just be delta d vector is equal to 80 meters minus 27 meters, which delta d is just equal to 53 meters. And that is basically all you need to do for questions with total displacement. That is our lesson on distance, position, and displacement.